In this section of completion corner, we will see how through a redox reaction or how through a concept of oxidation number we can identify the redox reactions. So there are two type of reactions in redox reaction. One is direct redox and other is indirect redox reactions. What is direct redox reaction? So it actually involves the concept of transfer of electrons in case of ionic compounds. So you have to transfer of electrons. So this we know that it is possible in ionic compound. So we have one example, zinc plus H2SO4. This will give you zinc sulfate plus hydrogen. So clearly this zinc is giving 2 electrons and therefore we zinc sulfate compounds. Here hydrogen accepting 2 electrons. So this we have seen in previous cases. So in indirect reactions actually concept involved in covalent compounds. So for covalent compounds we have to use new term that is called like oxidation number. So what is the meaning of oxidation number? Oxidation number is actually residual charge of positive or negative of an atoms appears to possess in a molecule when all other atoms from the molecules are removed as ions. So here you mark it, when all other atoms are removed from as ions. So let us take one example. Example is Cl2. So Cl2 is actually, it is formed by the Cl. This is the electronic configuration of Cl. So this is the bond. So if you break this bond, if you separate this molecule as a neutral, so we will get Cl having a 7 electron. The Cl having 7 electrons. So when 7 electron means there is no net charge. So oxidation of number of the chlorine becomes 0. Let us take another example, HCl. So HCl we can see here, HCl if you break this bond, so there is 2 electrons, so 1 electron is transferred over here. So this HCl will get 1 electron and Cl will get 1 extra electron. So due to 1 electron it will possess 1 positive charge. 1 positive charge. See, due to this positive, 1 positive. And due to Cl it is taking actually 1 extra electron, so it will have 1 negative charge. So here oxidation state of hydrogen becomes +1 and oxidation state of Cl becomes -1. Any atoms or ions, it can be positive, oxidation number can be positive, negative or fractional charge. Positive means electron has been removed and negative means electron has been added. Now what is oxidation number? So we can say once again, charge assigned to an atom in a species according to some arbitrary rules. So what are these arbitrary rules through which we can identify what is the meaning of oxidation numbers and how we can identify, how we can assign charge to them. So there are some rules. So for assigning oxidation number of an atom, we are giving oxidation number of an atom. So how we can assign number? So rule number 1, for neutral substance contains atoms of one element. So any neutral substance which have atoms of one element, example is helium. So oxidation number of helium is become 0, Cl2 is 0, acid 0, O3 0, P4 0, O2 0, sodium amalgam. So this is a combination of sodium and mercury, but still sodium is not losing an electron, so it will be 0. Again carbon, for example diamond or graphite or F2, all will be 0. So all these are neutral substance which have only one element, so oxidation number of this compound is 0. So next group 1. Group 1, these are the element hydrogen, lithium, sodium. So oxidation number of these element is +1, except when hydrogen is present of hydride end. So its oxidation number will be -1 because they have a capacity to take electron. Lithium hydride, calcium hydride, lithium aluminum hydride. So these are the compounds in which the oxidation number of hydrogen is -1. So now see next one. For group 2, these are the element belong to group 2, so oxidation number of these element is by default +2. For rule number 3, for group 18, oxidation number is 0 except xenon. Its oxidation number can be 0 to 8. Next is group 17, fluorine. This belongs to halogen compound. Oxidation number is -1. So we have seen earlier fluorine has oxidation number is 0 because this is a neutral molecule, but only fluorine this is having a -1 oxidation state. For other halogens, Cl, bromine, iodine, oxidation number can be -1 to +7. What is the meaning of minus? We said minus means electron has been added to the atom, and what is the meaning of plus? Plus means electron has been removed from the atom. Now see group 16. Group 16 is oxidation number of oxygen is -2 generally. For peroxide means O2 2 negative is equal to -1. How O2 2 negative? So we have one example, sodium peroxide. If you remove 2 sodium, oxygen will take 2 electrons, so it is 2 negatives. H2O2, if you remove 2 hydrogen, it becomes O2 negative. So this is the diagram of oxygen. Each oxygen gives 1 electron. So peroxide oxidation number is -1. Now next is superoxide. This is superoxide, O2 negative, so its oxidation number is -half. Example, KO2, potassium superoxide, sodium superoxide. So there in here oxygen in this oxide molecule, superoxide molecule is -half. This is barium peroxide. So this is barium peroxide. Peroxide is oxygen 2 negative. So oxygen 2 negative we have seen. So here oxidation number will be -1. When oxygen combined with fluorine, so oxygen dioxygen difluoride. So here oxygen will be +1. We can see +1 because halogen fluorine is -1. So you can see if you write here 2x -2 equal to 0, so you will get x equal to +1. So here +2. Halogen is each halogen atom is -1, so 2 halogen atom will be -1 into 2, and that definitely will get +2. For any sulfide, oxidation state will be -2. Next tool, algebraic sum of oxidation number of atoms in a neutral molecule is 0. Example, water. So you can see how to calculate the oxidation number of each molecule, how it is 0. So hydrogen is +1, so +1 into 2 plus oxygen state of the oxygen is -2. So this becomes 0. 2 minus 2 is equal to 0. You take ammonia. So ammonia, nitrogen. You take nitrogen, x atoms, hydrogen +1, so x plus there are 3 hydrogen, this is +1, so x plus 3 into +1 equal to 0, so x equal to -3. So oxidation number of the nitrogen is -3. Similarly, carbon dioxide. So carbon dioxide is x, oxygen, there are 2 oxygen, so each oxygen carries 2 charges, so here oxidation state of the carbon becomes again 4. Now in case of complex ion, sum of oxidation number of all its atoms is equal to charge on the ions. What is the meaning of this one? Let us take one example, ammonium. So here we don't know the oxidation state of nitrogen. So you take any algebraic number x plus 4 hydrogen plus each hydrogen BH plus 1 charge, and total charge is equal to +1. So this +1 nothing, this charge is put here. So just solve this equation. After solving x plus +1 -4 equal to -3. So oxidation state of nitrogen is -3. Similarly, sulfate. Here total charge of the sulfate molecule is -2. So we don't know the oxidation state of this sulfur. So put here sulfur as unknown quantity x plus there are 4 oxygens and there is 1 oxygen. Each oxygen bears -2 charge. So on solving we will get x equal to -2, 4 into -8. This side +8, so it become +6. So in this way we can find the unknown oxidation state of any other element which is not in the rule. Now what could be the minimum oxidation state? Minimum oxidation state for group 13 to group 18 is valence electron -8, valence electron -8, and maximum oxidation number will be number of valence electron will be the maximum oxidation. Suppose chlorine has a valence electron is 7. Chlorine has valence electron how much? 7. So 7 is the maximum oxidation state. For D block element it varies. So there is no fixed oxidation state for the D block element. In iron complex oxidation number is +1, but in other cases it is 0. So for example, iron NaOH2O 5SO4. So you can see iron we don't know the oxidation state, but here NO value of NO is +1, and water is a neutral molecule, so put oxygen 0. So 0 into how many molecules? 5. So whatever you will put it will be 0 only, and sulfate is -2, so it becomes again 0. So oxidation state of iron is x equal to +2 -1 equal to +1. Actually now we see what is valency, what is oxidation number. So valency is nothing but combining capacity of the element. It is always whole number. So 0, it can be 0, and 0 is valid for inert gases. What is oxidation number? It is actual or apparent charge present in a combined form. Actual or apparent charge. Charge can be real, charge can be imaginary, and it can be positive, it can be negative, it can be fractional form. Let us see some numericals to understand the oxidation number concept. So numerically, K2MnO4. So let us see what is said here. This comes to group 1 element, and this is the oxide. So for oxide we know the value -2. For potassium we know +1. So there are 2 potassium, 2 into +1 manganese. We don't know this one. So let us take algebraic form. So on solving we will get the oxidation number of manganese is +6. NOCl. So NOCl is a ionic compound. So split this ion into 2 parts, because if you Cl we don't know the actual, and nitrogen we don't know actual. So to find the nitrogen, if you split it, this is plus, this is minus. So now we know the algebraic sum of this molecule. This ion is +1. So nitrogen we don't know. So put here X -2. So we'll get the oxidation state of nitrogen, that is +3. Now next same thing, CaOCl2. This is called as bleaching powder. Bleaching powder. So bleaching powder, first you write the formula CaCl CaOCl. So this is +2. So that definitely this will be -1. This will be your again -1. So charge will be balanced. Any molecules charge should be, positive charge is always equal to negative charge. So OCl is -1. So we don't know the oxidation state of Cl, because here we are knowing. So -2 is oxide. This is your unknown quantity X. So -1. So X equal to +1. So here Cl we are getting 2. For this Cl is -1. For this Cl is +1. So there are 2 oxidation states present in this molecule. Now next is Fe3O4. How to find this one? So here we take Fe, you don't know, because this belongs to transition element. So put here X, there 3 into X, 3 atoms of oxygen. Here 4 atoms of oxygen. Oxygen we know -2, so total will be 0. So on solving we will get the oxidation state of iron is +8/3. What is the meaning of +8/3? +8/3 means this is the average oxidation state of nitrogen. How? See here. So this is the mixed salt. Mixed salt of oxides means two iron salt is there. One is iron oxide, second is iron 2 oxides, iron 3 oxides. So first you take the oxidation state of this one. This one is +2 and this one is +3. So total oxidation state of these 2 iron is how much? So this is your +2 into 1 iron. Okay, and this is how many iron? 3 into 6 total oxidation state. So this is 6 and this is 2. So total 2, total 6, and how many atoms are there? 2 + 1, 3. 3 is there. So write 2 + 1, 3. So total oxidation state is coming +8/3. So if any oxidation state is coming 8/3, this means that oxidation state is actually average oxidation state. One more example, Na2H2O3. So here sulfur we don't know the oxidation state of this compound, because this belongs to group 1. This is oxide. So again you take 2 into unknown quantity. This is 2, because 2 sodium is there. Again -3 into 2. 3 means number of oxygen atoms, and 2 means the oxidation state of -2 is oxidation state of oxygen. So on solving you will get X equal to +2. So +2 means one sulfur oxidation number of the one sulfur element is +2. So in this way we can find any oxidation number of any other element. So I will give you some problems for practice. Thank you.